All right, so we're in chapter 5 today. We're talking about, this whole section is on trig identities. Trig identities are equations that compare trig expressions. So they're equations that has one trig expression on the left side, one trig expression on the right side, and it shows how those two can be equal to each other, okay? So in the first section, we're going to start with the very basic trig identities. Some of these relationships between these trig functions are ones that you've already seen before in the last chapter or last year. So for example, first we start with the reciprocal and quotient identities, right? We know what a reciprocal is. It's when you flip a fraction over. So this one we know, right? We know already that sine is 1 over cosecant, and cosecant is 1 over sine, right? Remember this? We know this already. So if the sine of a function is 4/3, what would the cosecant be? 3 over 4. And the same, cosine is the reciprocal of 1 over, of secant. So cosine is 1 over secant. Secant is 1 over cosine. Tangent and cotangent are also reciprocals. So these are our reciprocal identities, right? We remember all these? Okay. Then we have quotient identities, and these are what happens when you divide two trig functions. So when I divide sine by cosine, that is a tangent, right? When I divide cosine by sine, that is a cotangent. These are extremely important, okay? Because they show up all the time. So if you remember, right? If you remember, what did we say before? We said that tangent was opposite over adjacent. Is that right? Yeah. Okay. So what did we say sine was? Opposite over hypotenuse. And cosine, right. So look, if I take sine over cosine, well, that's opposite over hypotenuse divided by adjacent over hypotenuse. Now in math, if you have a fraction divided by a fraction, if the numerators are identical, you can cancel them out. If the denominators are identical, you can cancel them out. And what does that leave you with? Opposite over adjacent, which is what? It's tangent, right? So you see that tangent is sine over cosine. You can do the same thing with the cotangent, okay? All right. So now it says to find the indicated values here. You have cosine of 3 over 4. You need to find secant of theta. This part is similar to similar to geometry. They're similar to geometry in the sense that, just like we did in the proofs, when we're using these, when we're solving these, we are bound to justify everything using specific identities. Okay? All right. So cosine is 3 over 4. What's secant? So the way I do it is, okay, what am I given? Cosine. Okay, given. What do I want? Secant. Then I ask myself, how is there an identity that relates the given with what I want? Is there an identity that relates cosine to secant? There is, right? Secant of theta is 1 over cosine of theta, which means it's 4 over 3. Now, this is the most basic type you could get, right? But I'm illustrating a point where I had to search for an identity, and I found it, and I used it, and I got my answer. And for this one, it's as simple as that, okay? Okay, so here, I have secant of x is 5 over 4. Tangent of x is 3 over 4. So these are my given. And I want sine of x. So I ask myself, how is sine related to secant or tangent? How are they related? Is sine related to tangent in any way? Yeah, how? Right. So sine over cosine is tangent, right? Tangent of theta is sine over cosine. Okay, so now let's see. I have tangent. I need sine, but I don't have cosine. Can I find cosine? Right. I can use this to find cosine, right? So cosine x is 1 over secant x, which means it's 4 over 5. And okay, look, I have tangent, I have cosine, I can find sine. Yes, right? So let's do it. So tangent is 3 over 4 is equal to sine of theta over the cosine of theta, which I just said was 4 over 5. Okay, so now look at this. This is sine divided by something, right? So I'm going to multiply both sides by the something. I'm going to multiply both sides by 4 over 5 by 4 over 5. No. That's if you're right. Okay, so there is a difference there. Cancels with this whole thing. And I get, okay, so some of these things reduce too. So 3 over 5 is sine of theta. Okay? All right. Yeah. No. Okay, so wait. Yes, mathematically, yes. You can do this with a triangle. However, in this chapter, you are only allowed to use identities. The purpose of this chapter is for you to learn the identities. So all the tests and quizzes are going to say triangles are not allowed. You must use identities because I need to make sure that you understand this. Now, for the final, you can do whatever you want. You can do identities. You can do triangles because over there, the point is, can you use everything you've learned to figure this stuff out? Okay, but for the purposes of this chapter, only this. Okay, a few notation questions here. So you see how the identities here, the identities here all have, are in terms of theta. So sometimes your questions are going to be in terms of x. I'm just going to say, I actually made a mistake in like what I wanted to say. I did what I wanted you guys to not do. If in the question the variables are x, I need you to keep them in x. So here I'm going to keep all of these in x, right? We are never allowed to just say sine equals 4 over 5. I've said this before. This is never allowed. It must have an angle, okay? Okay, so here's my favorite thing ever, okay? So suppose you have an angle on the unit circle, all right? Angle theta on the unit circle, okay? The sine and cosine values represent the vertical and horizontal legs of the triangle. Remember this? So look, here I have a triangle. It's a right triangle. The vertical side, I'm going to call it y, but it's also sine of theta. Is that right? Yes? The horizontal side, let's call it x, but it's also cosine of theta, right? Okay, so this is a right triangle. Is that right? Okay. So in a right triangle, is it true that a squared plus b squared equals 1? Yeah? So is it true that here y squared plus x squared is equal to 1? Right? Okay, but what is y? It's sine. So if I substitute, y squared is the same as sine of theta squared. X is cosine. So that's cosine of theta squared equals 1, right? Now, this expression, sine of theta parentheses squared, right? It's not the most common way of writing it. Instead, we normally write that as sine squared theta. Those two mean exactly the same thing. Okay? Yeah. Yeah, so if you did sine of theta squared, it means you're squaring the angle. That would mean something else. Okay, so now, here I'm going to rewrite this as sine squared theta plus cosine squared theta equals 1. Okay? Where did we pull this from? We pulled it from good old Pythagorean theorem, right? Because of that, we call this a Pythagorean identity. This is the most famous identity in trig. Sine squared x plus cosine squared x is equal to 1. Everybody knows this one. Sine squared x plus cosine squared x equals 1. So you need to know this one. If I ever tap you on the shoulder and I ask you, what's the first Pythagorean identity? Sine squared x plus cosine squared x is equal to 1. Okay? Does this make sense? Okay. So now, all right. So now look at what we're going to do. Just for fun, right? I'm going to take that identity, sine squared theta plus cosine squared theta is equal to 1. And you know what I'm going to do? Just for fun, I'm going to divide everything here by cosine squared, because what else would I do on a Friday morning, right? So let's divide cosine squared theta, cosine squared theta, cosine squared theta. Okay. What did we say sine squared over cos? What did we say sine over cosine was? Tangent. So look, sine over cosine is tangent. Sine squared over cosine squared, tangent squared. Sine to the fifth over cosine to the fifth, tangent to the fifth. Okay? So this is tangent squared theta plus, okay, what's this? Cosine squared over cosine squared, 1 is equal to, okay, look, now I have 1 over cosine squared. 1 over cosine is secant. 1 over cosine squared is secant squared theta. Yeah. Right, but that in trig identities, okay, so normally in math, we don't like negative exponents to begin with. That's never in simplified form, right? And then in trig, we also want to minimize the fractions. So instead of having 1 over cosine, we always want secant. So since 1 over cosine is secant, 1 over cosine squared is secant squared, okay? And now look at what happened here. Tangent squared plus 1 equals secant squared theta. Look, guys, that's the second trig identity, okay? Yeah.
So can you repeat why we divided it by cosine?
Just for fun, because I had nothing better to do, and I said, I wonder what happens if I divide everything by cosine. Because in math, you're free to divide any fraction by any number you want, and any equation by any number you want. You're free to add the same number to both sides. You're free to multiply the whole equation by a number just for fun. Okay? All right. So now I'm going to take that equation, that identity, the Pythagorean identity. And this time, guess what, guys? I'm going to divide everything by sine squared theta. You know why? Why am I doing that? Because it's fun, and what else would I do on a Friday morning?
Where you're going back to the original?
Yeah, I'm going to go back to the original, because, okay, I took the original and I divided by cosine, and it was so much fun. Now I'm like, you know what, let me just divide it by sine. Let's see what happens then.
You're not dividing the new one back.
No. No. That's too much fun. We're not going to do that. Yeah. Okay. So this, sine squared over sine squared, what is that going to give us? 1. Plus, what's cosine over sine? Cotangent. So cosine squared over sine squared? Cotangent squared. Equals 1 over sine squared theta Cosecant squared theta. And look, guys, that's the third Pythagorean identity. Okay? So there are three. So this Pythagorean identity that we came up with based on, a cute little triangle, it's got buddies. It's got two buddies. So now, all of the identities in section 1 and 4, you need to memorize them. Okay? But here, how many do you actually need to memorize? 1. You just memorize 1, okay? And then you can derive the others. And this one, first we're going to use it so many times, like you can't, even if you refuse to memorize it, you're going to end up memorizing it, period. But is it really something that you need to sit there and learn? Where did it come from? X squared plus y squared equals 1. Cosine squared plus sine squared equals 1. Okay, yeah.
So you find the second one, you just divide by cosine squared, and the third one sine squared.
Correct. Okay, so once I know this, that's all I know, and then I just divide. Okay, so here we go. Let's move on to some cool stuff. Cotangent of theta is 2. Cosine is less than 0. Anytime I have this, I need to go and look into the quadrants. Yeah.
What happens if there's one when you divide it?
No, that's meaningless. Yeah.
None of them become one.
Yeah, none of them become one, and then you can, and then you just get a cool identity, and you're like, oh, look, this is totally the same as the other two. Yeah, but we don't really use it as much. Okay, so if cosine is negative, which two quadrants are we looking at?
1 and 3 and 2? No. 1 and 3.
2 and 3. 3 and 2. Here and here. Cotangent is positive 2. Which two quadrants are we looking at there? 1 and 3. So our answers here are going to be in quadrant 3. Okay? Yes? Okay, so what does this problem tell us? If cotangent is 2, we need to find sine and cosine, right? Okay, so make sure we're all taking notes here, right? All right. We have cotangent. We need sine and cosine. So this is the given. We need these. So the question I ask myself is what? Is there an identity that does what? Right, so the question I ask is there an identity that relates what I have to something I need? So, is there an identity that relates cotangent to either sine or cosine? Well, let's see, there's a cotangent here, but that's a cosecant, but that's totally 1 over sine, so I can use that. Okay? So, I'm going to use...
How do you know that it's how do you know when you can use
When you can use what?
How do you know when you can use the Pythagorean identity?
Well, that's, okay, so if you can find any identity, okay, that you can use where there's only one unknown, you're free to use it. So in this case, I have a cotangent and a cosecant. I'm given the cotangent, I can find the cosecant, so that's a good one to use, right? Okay, so here, cotangent squared, that's going to be, cotangent is 2, so that's going to be 2 squared plus 1 equals cosecant squared theta. So 5 is cosecant squared theta. Now I'm going to take a square root, right? So cosecant of theta is equal to what? What? Just root 5? Thank you. Plus or minus root 5. Oh.
There's another way to get
Yeah. Okay. So what are we missing here? Plus or minus. But now We just said that we're in quadrant 3, right? So in quadrant 3, cosecant or sine is negative. That means it's negative. In quadrant 3, so cosecant of theta is negative root 5. Okay, but that's not even what I want. What is it that I want? Sine. So sine of theta is 1 over cosecant of theta. So sine of theta is negative 1 over root 5. All right, cool. So I got one of my answers. Okay, how am I going to get cosine? There are at least 2 different ways. What do you guys think? You can use an identity, right? So which identity can we use? I can use sine squared plus cosine squared. Is there another one I can use? Tangent equals sine over cosine. Which one's better? Whichever is going to minimize your mistakes. That one's better because they're both going to get you to the same answer. Okay? If it was me, I would do the one without the squaring because it's quicker. Okay? So let's see. So tangent of theta is sine of theta over cosine of theta. Okay, now look, this time, let's do it more algebraically, and then let's plug it in later. Let's solve for cosine of theta, okay, just to learn some more algebra skills, to hone in our algebra skills. Let's multiply both sides by cosine of theta. Okay, yes, we could have done it in one step. So I have cosine theta, tangent theta equal to sine theta. What do I need? Cosine, right? Cosine of theta is sine over tangent of theta. So cosine of theta is sine of theta. What is sine of theta these days? Right, negative 1 over root 5. And what was tangent? Do we know what tangent is? It's a half because cotangent is 2, right? So it's a half. Okay? So how much is this? That's it, negative 2 over root 5. Right? So you could do, times the reciprocal, or it's always, the outer over the inner. Okay? Yeah? You guys remember that from Algebra 2? So this is the year where we're going to use more algebra. This is the year where we should be quick with algebra, because once you get to calculus, whichever level calculus, you need to be experts at all these algebra skills. Okay, so we're going to hone those skills here. Okay. What is sine of 30? Do you guys remember? Yeah. 1/2. Okay. What's the complement of 30? 60. Right? Okay, so the complement of 30 is 60, right? So if I do 90 minus 30, I get 60. Okay, what's the cosine of 60? 1/2. Right? Okay, what's the sine of 60? Root 3 over 2. What's the cosine of the complement of this? 30. Root 3 over 2. Okay? All right, so that's like the special identities. That's just a coincidence. Could you guys take out your calculators very quickly? Can you please make sure your calculators are in degrees and tell me what the sine of 40 is to 3 decimal places? Yes. Sine of 40. What is it? 0.643. Okay, so you know what we're going to do now? Not sine, but cosine of, what's the complement of this? 90 minus that? 50. So tell me, Oh my, what did I do? What's the cosine of 50? Oh my God, it's like the same thing. Okay, so lucky guess there. Can you tell me what the tangent of 35 is? 0.700. So how about the cotangent? The cotangent of what number do you think will give me 0.700 based on the pattern that we're seeing here? Not 1 over 35. Why 55? Where'd you get that random number? 90 minus 35? 55? Is cotangent of 55 the same? Yeah? Okay, so guess what what did we just notice? Pattern. Huh? Complement.
Complementary angles,
Not the reciprocal.
they're
Because it's sine and cosine. Okay, so we're definitely dealing with complementary angles, right? 90 minus blah. And then there are these two functions that are related. Sine, cosine, tangent, cotangent, secant, cosecant. Now you know why it's the co of something. It's a function and then it's the co of that function. Yes. You know what those are called? I know, math people are very clever.
I always thought.
You know what those are called? The cofunction identities. Cofunction identities. So it's the function. You take the function, you take the co of the function, the cofunction, and they're the same for complementary angles. So the sine and the cosine. So this is where the buddies match up. Sine and cosine, secant and cosecant, they're like cosignatories.
Yeah, I always thought it was so. Sign. Oh my God. Screencast. So.
Huh?
Echo. You got home filling out the notes.
Yeah. So a few things to be careful for when it comes to these. So sine is defined as, or in general, these cofunction identities, sine is defined as cosine of pi over 2 minus theta. You see how it's the complement, right? The complement, yeah, exactly. And now you know why. Okay, she hit on a good point. Now you know why sine of 45, cosine of 45, tangent of 45, cotangent of 45, they're the same because they're the complements of each other. You see that? You see that? Isn't that? Yeah. So look, we always knew that like sine of 30, look, sine of 30 and cosine of 30 are not the same. They're not. But sine of 45 and cosine of 45, they are the same. Why? Because 45 is the complement of the 45. You see it? Because these are actually cofunctions. Okay, so let me tell you some other things that I need you to watch out for. There is a very important situation here where students usually miss. We're talking about complements. Yes? Okay, so if you have an angle 50, how do you find the complement? Subtract 90 minus 50 and you get 40. 90 minus 50. What if a student does 50 minus 90 and gets negative 40? Not cool. No, this is not. Okay, a complement must be positive. Must be 90 minus 50. It must be pi over 2 minus theta. Not theta minus pi over 2. Okay? That'll make a difference. That'll make a huge difference for the sine and tangent. Okay. Yes.
Why is the factor pi over 2 rather than... Oh, I get it.
You do get it. That's why, this is why a few homeworks ago there was that complementary supplementary question. Do you see that? When I go and I pick the questions, I don't just pick random questions. I read every single one and I go, oh yeah, this shows up in chapter 5. We need this now because we need to start talking about complementary angles. Okay? So there is a method to all this madness, right? Okay. So, okay. That's like the beauty of teaching, right? Is like making these connections. Okay, so now we're experts at this cofunction identities somewhat. We're figuring things out, right? So cofunction identities, they're the ones that are cos of the functions. Math people are very logical in how they name things. Cofunction, co of the function, cosine, cotangent, cosecant. And they are related so that sine is cosine of the complement pi over 2 minus theta. Hang on. We're not going to memorize these. Okay? We're not going to memorize these because then you're like, oh my God, it was theta minus pi over 2. No, it was pi over 2. We're not going to memorize them. We're going to know that this is the complement. And the complement is always 90 minus. It's always pi over 2 minus. Okay? We don't memorize, we learn, we understand. Okay. Now, huh? Oh, we're going to do so much. Okay. Here's what I'm going to do. I'm going to actually stop here and pick this up Tuesday morning.